All right, more stoichiometry. I know you're excited about this. This is, I think, is one of the more complicated one for people. Um, we use the same tools to calculate this as anything else, but it just seems like there's more moving parts. And so in this one, you have to picture somebody pouring two liquids together. The liquids are aqueous solutions, so most of what you're pouring in a liquid form is just water. But dissolved into it are these ionic compounds, and actually these ionic compounds are actually have been separated because when you dissolve an ionic compound into water, they dissociate. We're going to look at these as compounds, even though they're actually separate ions. We don't have a compound in each beaker. We have two ions in each beaker, four ions total. But when we pour them together, two of the four do not like to stay apart. They like to stick together and they'll form a solid. And you can see from our subscripts that the solid in this case would be iron 2 phosphate. The precipitate in the problem is the solid that comes out. Just like having a snowstorm, you have a solid that falls from a gas. We're going to have a solid that falls from a liquid. So that is our precipitate. And they give us volume and concentrations for each of the reactants. So one thing we can look at in terms of being helpful for this is we don't have to deal with KCl at all. So what we're going to do is we're going to start and figure out the moles of the first one. So figure out moles of A using molarity times liters. And then we're going to go to moles of B, and B is going to be what they're asking for, which is going to be the iron 2 phosphate. And then we're going to go to grams of B, which is again the iron 2 phosphate. And we got to go to grams because it says what's the mass. Looking for mass, looking at grams, that's what we need to do. And then, since we have both things, we don't know which one actually runs out, we do it all over again, except we're going to do the other reactant. Also is going to be an A. It's not the same one, but it's the other reactant. We're going to go to moles of B, the same iron 2 phosphate, and then we're going to go to the same grams of B. And guess which one we pick as our answer? The smaller of the two. So the smaller of the two would be our theoretical yield in grams. The reactant that got you there will be our limiting reagent, and the other one will be in excess. So let's do that first, which is problem A. And then when it says what is the concentration of the excess left over, we have to tackle that in a different way. So these are two separate problems. Let's figure out the first one now. Okay, as you can see, the blue is going to be the iron 2 chloride, the red is going to be the potassium phosphate. I converted both of them to moles first, so now we're in the second box. Then I converted each of those to moles of the question, which is the precipitate, which is the solid, which is the iron 2 phosphate. And then I went from the third box to the fourth box because we're looking for grams, and I got a formula weight of 452.46. And I got two answers of 5.84 and 4.91. This is my answer, and this is a bunch of crap, right? It says if we use all of the iron 2 chloride up, we will make this much, but we can't because the point at which we make 4.91 grams of iron 2 phosphate, the potassium phosphate runs out. If the potassium phosphate runs out, we have no more phosphate, we can't make any more. So that's our answer for A is 4.91 grams. If you notice throughout, when I had an option, I kept 4 digits because I knew I'd be rounding to 3. The molar mass is 5. All the other ones are given as 3. So in the first one, I kept an extra digit. The second one, the extra digit would be a 0, so it wouldn't count. So just in terms of sig figs, I kept an extra one throughout. Okay, now we're going to answer B, which is, I think, probably the most tricky one. So the excess is going to be the iron 2 chloride. We're going to subtract moles from moles. We already know how many moles we have right here. We got to figure out how many moles we used. And the way you do that is you go from the limiting reagent, which is the moles of the potassium phosphate, and we're going to do one conversion in this case to the excess reagent. So we go from moles to moles, and we'll have moles of the iron 2 chloride, and this will be the amount that is used. Whenever we calculate through the 4 boxes, if we're calculating a reactant, we're calculating used. If we're calculating a product, we're calculating formed, and that is if we use and if we form, but that's what we're calculating. All right, in green, I went from the limiting reagent to the excess reagent. And I'm doing it in moles because we have to deal with molarity. Molarities can't subtract, since when we poured it together, even before the reaction happened, when we poured it together, but the volume has increased for both essentially because they're both in a 125 milliliter solution. So both the concentrations have already dropped just by pouring them together. And then once they react, they're going to drop even further. One will be completely used up. That's the potassium phosphate. So we can't use molarities. We have to use moles. And now we need to subtract the moles. So I have the 0.03875 moles of the iron chloride that we have. I calculated how much we use, and I subtracted it to get the 0.062 moles left over. Now don't forget, when in doubt, answer the question. And the question is, what's the concentration? Moles are not concentration. Moles are counting number of items. This is exactly what you have, not the concentration. Concentration is a ratio. We need molarity. Molarity is going to be moles over liters. So what we're going to do is we're going to grab the moles, which is going to be the 0.0, you know what, that's another zero there, 0.062 moles of the iron 2 chloride. And we're going to divide it by the volume, and the volume is the total volume in liters. So we have 25 milliliters and 100 milliliters, that's 125 milliliters, which is going to be 0.125 liters. And this molarity will come out as 0.050 molar, run out of space, my bad, FeCl2. We lost a sig fig when we subtracted, and that's okay. That is our answer, is 0.050 molar of iron 2 chloride. Hope this helps. All the other ones are different numbers, everything else, but it's the same type of process. Again, when in doubt, turn it to moles. If we deal with molarity, you need moles. And volumes always add when we pour them together, and the volume of the solution won't change if there's a reaction. All right, I'll see you guys later.